Hey guys, so today we're talking about finding the apothems in polygons. We talked about finding the areas with the apothems, but now we need to use the actually use the shapes and triangles and everything we have to find the apothems themselves. So a reminder, the whole point of the apothem, A, right, the distance from the center to a side. Remember, the apothem is the distance from the center to the side. Right, the whole point of it is it's what lets us find the area of our polygon. So the whole point is finding the area, the space inside of the polygon. Well, anytime we have a shape that's more than 4 sides, there's no real easy way to do that. So we split it into the triangles like this. Right? So our first step is we can split our polygons into triangles. Once we've done that, to be able to get anything else, we really need to find out what each angle measure is. Like for the whole polygon, what each one of these angle measures would be. I need to know this entire chunk. So to do that, I need to use my formula for finding each angle measure in a polygon. You guys may remember this from quadrilaterals. I do the sides minus 2 times 180. And when I'm all the way done, I go ahead and divide that by n. Right, where n is my number of sides, that gives me the degrees in each angle. So here I can go ahead and count how many angles I have. I have 1, 2, 3, 4, 5, 6. This is a hexagon. So I'm going to do 6 minus 2 times 180, and that's going to get me 720. And I have a hexagon, so I'm going to find each angle. I have to divide 720 by 6, and I get that it's 120 degrees. So this angle over here that I've marked off is 120 degrees. But obviously, if I'm trying to find this apothem, I'm going to need the angles in this triangle specifically. Well, hey, we've cut all of these angles in half because this is a regular polygon and these are all congruent triangles. So to find this angle, just this one I'm interested in here, or this one, they're the same thing. I can go ahead and divide 120 by 2. And I'm going to get 60 degrees. So each of these angles is 60 degrees. So ultimately here, at this point, the reason we're finding this angle is we should know what S is. They will have always told us what each side is. Let's go ahead and say it's 5. It doesn't matter. So that means this would be 2.5. Just this half, right? Because it's half of the whole bottom. The whole point of me doing this is, again, I'm interested in the apothem, which is part of my right triangle here at this part of the circle. And something we remember about right triangles is you can always find the last side if you know an angle and another side. So we're going to go back to trig. This is going to go back to SOHCAHTOA, right? Here I know this angle, and I have the adjacent, and I need the opposite. Opposite over adjacent is tangent. So that's going to be my big focus right now. And to find A, so I'm finally getting there, I know that the tangent of this 60-degree angle that I went through and found is the same thing as opposite is A over adjacent is 2.5. So if we think about our steps, right? Step 1, we found each angle. We found each angle in the triangle, and then we used trig. That was the whole point of finding each angle in the triangle. Once we found each angle in the triangle, we could use trig to find the apothem. Because from here, tangent of 60 is a number, so A is whatever you get when you multiply 22.5 times the tangent of 60, which you should do in your calculators. When you do that, you get that the apothem here is roughly 4.33. Again, all I did was type in 2.5 times the tangent of 60. So our 3 steps, there are essentially 3 steps you have to follow all the time, no matter what, right? One. Step 1 here, find each angle in the polygon. Step 2, find the side angles in each triangle. Remember, we break it into triangles, and I need to find the base angles, I should say. Then once you've done that, you use trig. Right, so we're going to keep using the tangent ratio, almost the exact same process as we used over here. So I'm going to do another quick example. I'm going to justify why the apothem should be this. So first, let's go ahead and break out all of our triangles. That seems like a little bit much. So again, I want all of my angles first, so I've got 1, 2, 3, 4, 5, 6, a hexagon again. So I'm going to go ahead and do 6 minus 2 times 180, which we said was 720. Go ahead and divide that by my number of sides, and I get that each is 120. Then I want the degrees in my angle. So I cut that in half. So I get 120 divided by 2 is once again 60 degrees. And I know the whole bottom is 12, so this part that I'm interested in just here is 6. I still have this right angle because I still have a right triangle. So tangent of 60 degrees equals my apothem over 6. Or my apothem equals 6 times the tangent of 60 degrees, which is about 10.39. Once you've gotten this, guys, you can go ahead and use our formula. Remember what the formula is. We're saying that the area equals 1/2 times the apothem times the number of sides times the side length. Once you know the apothem, you can use your formula to find the area of the polygon. Good luck, guys.